All right. Hello, hello. Welcome to tonight's free prep hour. My name's Jerry. I'm going to be your instructor this evening. And tonight I wanted to focus on probability. So probability is one of these kind of grab bag quant areas that we're going to see occasionally. So I'll say right now, if you're just starting your studies, this probably isn't the most important thing. There's a lot more kind of fundamental topics that you're going to see way more often, but probability is one of those things you're going to reliably see anywhere from 2 to 4 questions on the test. And so if you're at a point in your studies where you're like, hey, I've got the basics, and now it's like, how do I get some of the tougher stuff? How do I raise my score just a little bit? Probability might be one of the ways to do that. It also might be one of the topics where you're like, you know what, I kind of hate this. And you can get away with not knowing it. That just means you're going to have to take one of those other grab bag concepts like combinatorics, for instance, and maybe get better at that, or sequences or patterns. But probability I find a little bit fun. I find it kind of interesting. And so what we're going to do today is look at kind of the basics of how these work, and then we'll work through some increasingly difficult problems with them to work out how to do these probability problems. So to start out with, just the very basics. We've got a dice, 6 sides, and we roll it once. And I want to know, what's the probability of rolling a number less than 3? And I want to know the probability of not rolling a number less than 3. And I'll give you a minute to figure this out. When you have the answers, please send them to me in private chat. Okay, so this comes down to, what does probability mean? And the basic definition of probability is that probability is successful outcomes over total outcomes. And so if we want to find the probability of rolling a number less than 3, we need to think about, well, how many successful outcomes are there and how many total outcomes are there? Well, numbers less than 3 are 1 and 2. So there's 2 successful outcomes, and there's 6 possible outcomes overall. So this probability is going to be 2/6 or 1/3. The probability of not rolling a number less than 3, well, we could figure that out 2 different ways. One would be to say, well, the number's more than 3 over the total, right? So a success here would be a number 3 or more. So that would be 4/6 or 2/3. The other way we could do it, though, is to know that probability is also 1 minus failures over total. So it's successes over total, or 1 minus failure over total. 2 different routes to go here. And something I'm hoping we're gonna have time for today is, when is this gonna be easier for us to use? Most of the time it's this, but sometimes some kinds of problems, this is gonna be the way we want to go. So one other thing important to know, probability is always gonna be between 0 and 1. The least it could be is 0. If there's a 0% With 0 probability, right? What's the probability I roll a 7? The most it could be is 1. What's the probability I roll a number? Okay, 6 out of 6. So let's try this out. 2 more questions here. See how you can do on that. And I'll just put that definition up on the board here. Successes over total. So I'll give you a minute. Send me the probabilities to these 2 when you've got them. Okay, so for this first one, a success would be that we pick a red marble. There's 5 red marbles over 24 total. The probability picking a not yellow marble, we can either add up the non-yellows over 24 or do 1 minus the yellows over 24. They both get us to the same way. So let's try one out, a little bit tougher. These were kind of like intro, how does the mechanic work? We're now going to try a GRE style question that's going to take a little bit more work to figure out your total outcomes and your successful outcomes, but it still comes down to the same formula. So I'll give you 2 minutes to try this. Send me your answer when you have it, please. Okay, I'm going to stop you there. So, a couple of difficult things here, right? So first of all, the average, it's a statistic term, is the sum over the number. And so we've got 10 consecutive positive integers, and consecutive just means one after the other. So for me, I would approach this by saying, all right, let me look at the easiest case. And this is often a good strategy on the GRE. Pick numbers, make it concrete. So we're going to do that here and pick the easiest case. And from here, I might figure out, okay, do I need to test other cases, or is this going to tell me what's going on? Now, to get the average of this, I could add all of these up and divide by 10. Or maybe I know a rule that for consecutive integers, the average is equal to the median. So I can take the median of these two, which is going to be the average of these middle two numbers. I know I'm giving a lot of like stats stuff here that maybe feels unfamiliar. If it does, that's okay. So 5.5 is my center here. And let's just deal with this before we think about other cases. What's the probability that the number selected is greater than the average? All right, so what's the probability my number is greater than 5.5? Well, 1, 2, 3, 4, 5 cases. Oh, so 5 out of 10, which is equal to 1/2. So my answer here is C. Now, if you're taking a smart guess, you might think like, okay, I can't figure out how to get the average, 10 consecutive integers. The average, it's probably the middle number, right? What's the probability it's bigger than the middle? That gets you there, even though it's inexact. Now, if we were to pick other numbers, let's say like 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, we'd find the same thing. It would again be between 25 and 26. And it wouldn't matter if instead of this, I started 22 and went up to 31. My average would still be those middle two numbers. It would be right in between them. So maybe I do this, if I were doing this in the test, I'd do it with the simplest case, end up with this. Maybe if I'm really unsure, mark it, come back later and try it with a different set of numbers. You could do it algebraically, calling it like x, x plus 1, etc., but that's awful. I would highly recommend against it. Okay. So let's try one more like this, using our straight up probability definition here. But again, in a more complicated case where we have to think kind of hard about how to find these things. Send me your answer when you have it. Okay. So we've got a 24-sided dice here. Each number featured exactly once. Pedro is going to roll. We want to know the probability that the number showing is a factor of 24. So we know our denominator here is going to be 24. The question is, how many factors of 24? So we're looking for the number of factors of 24 over 24. Okay, so for that, we need to just make a factor tree. And here's a number properties tool. So we can think about these factors as occurring in pairs: 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then I get to 6 and 4, and I've already repeated myself. So I see there's 1, 2, 3, 4, 5, 6, 7, 8 factors. So I've got 8 over 24, which is equal to 1/3. In a problem like this, if I put 8 over 24, that would work. It's anything equivalent to 1/3 is going to work for a fill in the blank question like this. So we're seeing probability in this case is just knowing this formula. And then it just becomes, how do I use this other technique, these number property divisibility techniques, to then figure out this? But something I would suggest is start the problem by setting up what you need. As these get more and more complicated, it's really helpful to have a sense of, okay, I need these two pieces. I know this piece, I need to figure out this piece. That can give you a guide of how to approach the problem. And in the GRE in general, as these word problems get more and more complicated, the best thing you can do as a test taker is to focus on what you actually need. That's going to help you break the problem down into pieces and make it actually possible to solve it. So far, what we've been doing is dealing with the probability of one thing happening. I rolled a dice once, I rolled a 24-sided cube once. We pick one number from a set of 10. I'm going to change it a little bit. We're now going to roll our dice twice. So the term we would use in probability talk is to say, we're now dealing with two events. Roll 1 and roll 2. And question is, how do we deal with that mathematically? So I'm going to give you a second to try this, see if you know the answer. Send it to me if you do. Let me know if you don't, and then we'll work through them together. Okay, so if we're looking here for two prime numbers, the way we're going to approach this is, first of all, we need to know which numbers here are prime. It's another number properties thing kind of sneaking in the back door here. So the numbers that are prime are 2, 3, and 5. 1 is not prime. 4 and 6 are also not prime. 2, by the way, is the only even prime number. So we're looking for two prime numbers here. And when we've got more than one thing happening, when we have multiple events, and we're looking for one thing and another thing, we take the individual probabilities and multiply them. So the probability of a prime on the first roll times probability of the prime on the second roll gives us 1/4. Now, what's the chance of rolling exactly one prime number? Well, in this case, we have to think, well, how could that happen? It's either I get a prime on the first roll or I get a prime on the second roll. So in that case, where I have an or, I need to add probabilities. So I've got prime and non-prime, because that's an and, I multiply, gives me 1/4, or non-prime and prime. So or 1/4, I add those together and say it's a 1/2 chance that I roll exactly one prime number. So when we have multiple events, one of the things we need to be looking out for is, are there multiple success scenarios? In other words, where I get a prime and non-prime, or a non-prime and prime. Within each scenario, though, we're dealing with multiplication. It's only when we're saying this scenario or this scenario that we add them together. That distinction can sometimes be a little confusing at first. But the thing I'll say is, for the most part, you're going to be multiplying things. It's only when you're like, it could go down one way or it could go down a totally different way that we add them together. So let's try this out now. Keep practicing this with multiple events. Here we've got a coin flipped 3 times. So 3 events. See if you can figure out how to do this. I'll say here, this is a quantitative comparison problem. It's a kind of problem unique to the GRE, and your job is to pick the bigger quantity. So I'll let you get started calculating this. And as you do that, I'm going to put down what the answer choices are for So for this case where we have multiple events, one way we could do it, of course, is to say if probability is successes over total, we could list out what are all the different ways this could go down, write out all those possibilities, and then say, okay, how many successes are there? There's 1 out of 8 total. And so we get 1/8, there we go, which is bigger than which is less than 1/6, excuse me. So our answer is B. But obviously this is a waste of time, especially if it's like 3, even 4 flips, or we're rolling a dice 3 times. We don't want to have to list everything out. So instead, we're going to use that other method I showed you before, where we take each probability and we multiply them together. And that gives us 1/8, which is less than 1/6. Now, let's change this a little bit. Now I want to know the probability all 3 are heads or all 3 are tails. We've got an or. See if you remember what to do with that. Send me your answer when you have it, please. Okay. So to get this or result, we need to think about each individual result. The result of all heads and the result of all tails. So the result of all heads, we get of heads and heads and heads, or tails and tails and tails. So we end up with 1/8 plus 1/8. And here we still have 1/6. 1/4 is going to be bigger, and our quantity A is our answer. So I'd like to move on now to a little bit more complicated ones. So dealing with this same idea of multiple events, remembering for and heads and heads and heads, we multiply. For or, all heads or all tails, we add. Let's try that out in the context of a more GRE level problem. Send me your answer when you have it, please. Okay. So we're looking for the probability that we get a heads and a 6. So it's sometimes helpful to kind of write out slots for these probabilities and say we're looking for the probability of a heads and the probability of a 6. That and tells me I'm going to multiply here. It can be helpful to write this out first, and then my job is just to fill in these individual probabilities. So the probability of a heads, they tell me, is 1/2. And the probability of any given number is 1/6. So to get a 6 would be 1/6. So it's 1/2 times 1/6, which is 1/12. And our answer is B. Good. Hopefully this is becoming a little clearer. Let's keep going. We're going to start upping the difficulty a little bit. Okay. So probability for any given day is 1/6 to have rain. We want the probability that it rains on Monday and Tuesday. So we're looking for rain and rain. Each one is 1/6. So we just multiply. We get 1/36, which is choice A. So far, this is pretty similar to what we've been doing. We're now going to start to see how some wrinkles might show up in that. Okay. So we want the probability of black chip number 3 and then white chip number 3. So if we think, okay, there's 12 chips total. We're looking for black chip number 3. That's one of the chips. And then we might just think, cool, we want white chip number 3, another one. So if I'm going to label these, right, black chip 3, white chip, white chip 3. But there's a problem here. Because once I've pulled this first chip out of the bag, I no longer have 12 chips total. So that second probability has to be different. Instead, there's 11 chips left. This is a case where we have probability without replacement. So like you pull a marble out of the bag and you don't put it back. That's going to change the probability. From event to event. And so we need to be aware of that. So in this case, it's actually 1 over 12 times 1 over 11, which is going to give us 1 over 132. Notice again, I'm multiplying because it's and black chip 3 and then white chip 3. I want to take a moment to just address what's a common question at this point when learning probability, which is, for this second piece, how do I know that I got black chip number 3 on the first one? Don't I need to account for all the cases where I didn't? And the answer is no. This probability is, what's the probability the second chip is white chip 3, given that the first one is black chip 3? And since that's all we care about is when this happens and this happens, we don't need to think about any other cases. That's kind of a conceptual answer. A kind of more pragmatic answer is, don't worry about it. Just take the probability that you care about for each probability. Somebody's asking, does that mean the number of the chips do not matter? No, it totally does. It matters that there's 12 of them and then 11 of them. If what you mean is like that it's the number 3, it does matter in that there's only 1 3, right? If we look at the black chips, there's 1, 2, 3, 4, 5, 6. So it matters that there's only 1 3. If instead it were something like this, where it's like there's 1 and then 2 2s, and then 3 3s and 4 4s, well, then that's something different. But the 3-ness of it specifically matters no more than rolling a 3 on the dice. So as we're doing these probabilities with multiple events, we need to ask ourselves, are we dealing with replacement, like rolling dice or flipping coins where the probability is constant? Or are we dealing with no replacement? We're pulling jelly beans out of a jar. It's going to change our total, so the probabilities change. As you go into a problem, ask yourself, which case am I dealing with? Let's try another one, again, a little bit harder. Okay. So we've got a pile of 6 green chips labeled 1 through 6, and a pile of 6 blue chips labeled 1 through 6. Tariq is going to pick 1 chip from the green pile and 1 chip from the blue pile. We're looking for the probability that both give a number less than 4. So for our green, less than 4, we want to think, okay, there's 6 total. And how many are less than 4? 3 of them. For our blue, less than 4, we have to keep in mind these are separate piles. So this is actually a case where there's replacement. Because there's no overlap between these piles, this also is going to have 6 possibilities, 3 successes. We multiply these, 1/2 times 1/2, we get 1/4, which is less than 1/2. So this one's a little bit of a trick question after that last one, right? We still have got different colored chips, but because they're kept separate, these probabilities aren't going to change. Okay, let's try another one. Okay, so we're rolling a dice twice. I want to know the probability the sum of the 2 rolls is 8. So to do this, I need to start out by saying, okay, well, what are the different ways I could get a sum of 8? I could get 2 and 6, 3 and 5, 4 and 4, 5 and 3, or 6 and 2. So I see these different possibilities. Now, one way to do this would be to say, well, what's the probability of each of these individually? Each one individually is going to be 1/6 times 1/6, or 1/36. And I see that there's 5 of these different things. So it's this, or this, or this, or this, or this. So I do 1/36 5 times. gives me 5 over 36, choice C. You can also, just as a shortcut, when you've got multiple success scenarios that have the same probability, multiply by the number of scenarios. Just instead of saying 1/36 plus itself 5 times, we could just do 1/36 times 5. So there's 5 different ways the same probability can go down. The other solution here would be, if we see there's 5 success scenarios, we can ask how many total cases. And for that, we would need to use combinatorics, which is a whole other bucket of worms, and say we've got, for the first roll, 6 possibilities, the second roll, 6 possibilities, 36 possibilities total, so 5 over 36. Again, we're not covering combinatorics tonight. It's a whole other thing, but sometimes combinatorics can be helpful in probability problems. All right, we've got time for one more. I'm going to make it a little bit tougher and hopefully end up with one final lesson for you all. Let me make sure this is it. Great. Send me your answer when you've got it. Okay, so we're rolling this dice twice. We want the probability at least one of the rolls is greater than 4. So let's think about the ways this could happen. If either the first is more than 4 and the second is less than 4, or the first is less than 4 and the second is more than 4, or they're both more than 4. So there's 3 different ways this can go down. We've got multiple success scenarios. So this is an or case. This or this or this. And we might notice these 2 are going to have the same probability. It's just changing the order. So let's figure this out. The probability 1 is greater than 4 is going to be 2 over 6. The second probability less than 4 would be or not greater than 4, 4 over 6. So we end up with 8 over 36, or if we're going to do a little bit more simplifying here, 2 over 9. This is going to have the same probability, also 2 over 9. So far, we've got 4 over 9 as our probability. And then we also need to think about this case, which is going to be 2 over 6 times 2 over 6, or 1/3 times 1/3, so 1/9. So we add these together, we get 5/9. And that works, but it's a bunch of work. So when we've got multiple success scenarios and you see something like at least or at most, you want to ask yourself, which is easier? Successes or failures? What do I mean by that? I mean, what's the only way that this fails? The only way this fails is if both of them are less than 4. So what I'm going to do instead is do 1 minus the only failure scenario. So 1 minus the probability it's less than 4, or 4 or less, which is 4 over 6, times 4 over 6. This is going to let me do it in one calculation. Which is quicker. So when you see you've got this at least or at most, oftentimes the easier method is to do 1 minus failure. Because there are fewer failure scenarios. So that's all the time we've got for right now. We've got a couple minutes to take questions about probability, and then I'll end the recording and I can take other questions you might have about the GRE. So any questions about anything we've covered so far tonight? Okay. Well, with that, I want to thank you for a wonderful evening. If you're watching this on YouTube, I hope this was helpful. If you're here tonight, I hope you found it also helpful. I'm going to end the recording now. And for those who are around here, I'm happy to answer any questions you might have about the GRE or anything else.